Welcome friends, welcome back to our channel Crystal Learning. So today we will see the subject theory of machine. In that we will see the concept of gear ratio. Until now I didn't have the confusion on this topic. I have been teaching for many years, and when I have been a student also, then also there was no confusion. But recently, just before one day, after reading the different books, I got this confusion. So I decided to make a video on this and see what is the confusion and what is the solution for that confusion. So this question came in UP, that is Uttar Pradesh, SSC-JE Mechanical Examination 2022. Because of this question only, the uh, confusion came. So this question says, if the effort gear has 32 teeth and load gear has 160 teeth, calculate the gear ratio. So the formula is number of teeth on driven, that is also known as follower or load, because load is put on follower wheel, and uh, effort is on driver wheel, or you can say input wheel. Okay, just these new terms which came in this gear ratio is effort and load. So you have to be clear that load goes with follower or driven and effort wheel goes to input or driver. Both are the same thing. 160 upon 32 and 5 is the answer. Okay, gear ratio. So in the same paper, they asked similar type of question again. The number of teeth in driving gear is 40 and number of teeth in driven gear is 20. So the same formula, that is driven upon driver 20 upon 40, 1 by 2. But now the twist comes. When you see the provisional key and the final key, this is paper code E, 21 number and 83. In provisional key, the answer was AA, that is 1 by 5, and in final they changed this to B and they have went ahead. So actually I won't comment much on this state examination authority, because they just copy their questions from any sites or any book that is not authentic. They never cross check the values, okay, that what is the theory and concept. And in India, if you challenge them and they are only the sole authority, whatever they will decide, you have to accept it. So I won't go into detail that what should be done in that. Just I am here to discuss the confusion from my end, or a person who has studied the concept of this gear ratio in detail. If you just argue with them, then he will understand. But this state authority examination board, you can't argue with them. So let's go ahead with our concept. So if I say this both answer is right, 1 by 5 and 5 in this question, and in this question also 1 by 2 and 2 is right, just it is the inverse. Okay, just it is the game of being inverse. So both of the things are right, because we will see in the coming extracts or the references that both of the terms are used for gear ratio. Okay, so to calculate that gear ratio, gears are made from friction wheels that are rotating. So for no slip of two surfaces, there won't be any relative motion, and the tangential velocity of the gears will be same. Suppose these are two rollers, okay, they are mating, not intersecting, they are just mating. So at the contact surface, this tangential velocity will be same, v1 equal to v2, that will be r1 omega 1. You can just revise some theory, because I am not here to teach the theory, I am just here to discuss on that confusing point. Okay, so now we got the relation, this formula, that is number of revolution is inversely proportional to radius of wheel or diameter of the wheel. Just don't confuse or just mug up this n1 is for rpm, because in some references n1 is also used for number of teeth. Okay, so whatever symbol you are using, just see that for what that symbol is being used. So circular pitch is another term, that is distance measured along the circumference of pitch circle from one point on one tooth to corresponding point on adjacent tooth. So for two mating gears, circular pitch will be same. So it will be relation P equal to pi d1 equal to t1 upon equal to pi d2 upon t2. You just see the diagram of the pitch circle and two mating gears. From here, from the diagram, you will get this point clearly. That is circular pitch of the two mating gears must be equal. Okay. So here, from here you see that diameter is directly proportional to T, that is number of teeth. Or from previous relation you can just use inverse relation with number of RPM, N2 upon N1, okay, inverse relation. So this thing you have to know, okay. So in this first extract, velocity ratio is defined by angular velocity of driven or follower upon angular velocity of driver. Okay. So this was a famous book that we refer in our graduate course, that is R.K. Bansal, Theory of Machine, then S.S. Rattan, Theory of Machine. This is the foreign author book defining same, that is angular velocity of the follower, that is driven upon driving gear. Okay. These names are given, so you can search on Google book. So in extract third, it is saying input upon output shaft gear ratio, and there will be also confusion between the names. That is gear ratio. It is using that you can also use movement ratio or velocity ratio. All the terms mean same. Okay, according to this author. So it is saying input upon output. Let's go here. Input upon output. As I told, input is driver and output is driven. Okay, driver. Here, according to this, it is omega upon driven, driven upon omega of driver. Just see inverse relation is there. So this is the game which is being there in different authors book. Different notations are being used. Means inverse relation are used. So that's why in the starting I said both the relations are true. Okay. So there are many extract which I have given. Here it is using a new term, that is train value as driven upon driver, that is written as inverse of gear ratio. Okay, train value. Another term is used transmission ratio. For them, transmission ratio or gear ratio for this author is same. Here it is defining gear ratio in number of teeth and transmission ratio as angular velocity, driving upon driven. And here pinion will be always the input shaft, that is driving gear. So here see angular velocity is driving upon driven. Okay, driving is at numerator and driven is denominator, and this number of teeth is just inverse relation. So it is using same term for this order. Transmission ratio and that gear ratio is same. But in next reference, it is saying that inverse value of velocity ratio known as gear transmission ratio or just train value. I is, that is train value or transmission ratio, that is output upon input, and velocity ratio is input upon output for this reference. Another reference you just see output upon input, velocity ratio, here input upon output. In between foreign authors there is a tussle going on. So now this author is saying velocity ratio is also known as speed ratio, mesh ratio, gear ratio, transmission ratio, movement ratio. For this author, everything is same. Okay, it is defining a new term, that is inverse of velocity ratio, that is ratio of torque. Okay, so here for this another extract, that transmission ratio or train value, it is same, but this author velocity ratio, transmission ratio. Okay, so this is defined here. So confusion can be in names also, but that is the later part. So there is another extract, gear ratio is input shaft upon output shaft. Now one interesting point will be there in extract 10. It will try to justify that with which formula you should use. Okay. So for him, velocity ratio, transmission ratio, and speed ratio is same. That is speed of driver upon follower. Okay, driver upon follower or driven. It is saying that it is also in practice to define velocity ratio as the ratio of speed of follower upon driver fluid. That is N2 upon N1. That is speed of follower upon speed of driver. Okay, but it is saying if you define like this, then in this case what will happen? You have to select bigger pulleys, which is uneconomical. So this point we will understand through example. In this example, it gave that velocity ratio is 3 driving pulley RPM is 4 RPM and driven pulley diameter is given 300 mm. So we have to calculate the RPM and that diameter of driving pulley. Okay. So for choice 1, that is gear ratio defined as N driver upon driven. Okay. N1 upon N2 equal to D2 upon D1. So N2 you have to calculate, that is N1 upon I. D1 you have to calculate, that is D2 upon I. Okay. So D2 was given 300 mm. So D1 we have calculated, that is driver pulley, that is 100 mm. So here we see we get diameter 300 mm and 100 mm for the given velocity ratio. But in the second choice, we have just inverse the relation, that is driven upon driver. So same formula, N2 upon N1, just we have reversed the term in denominator and numerator, that D1 upon D2. Here we have to find N2, then it will be multiply term and D1 will be multiplied term. Okay. So RPM is getting increased, but we are not concentrating on RPM. We have to see the material usage. So here the diameter of driver is 3 into 300, that is 900 mm. So here you see in first case there is just only 300 plus sorry 100. In second case we got 300 plus 900. So more material is being used. So this choice is uneconomical. So it is just saying about economical and uneconomical. It is not saying that any formula is wrong. So both of the formula is wrong, as you see in different extract or different resource or books, different formula used. So nobody can say that this is wrong, that is right. Just in the terms of economical and uneconomical sense, you can say you have to use which term. So final conclusion was according to extract third, they are using the formula in this. I have also tabulated this table. This table you can see n is RPM and number of the inverse relation is there for extract 1. It is saying this one right, extract 2 this one right, and extract other extract this one right. There both terms are being used for the gear ratio. So I have made this lecture just to make clear that both of the definitions are right. Before that, I was quite amazed to see, because I was referring different resources, different books, so I was getting confused. But there, I believe after discussing these points, you got to know that both of the definitions are right. And so if you go to any learned person who knows about the gear ratio, then you will get definitely marks. But if you go to like state examination authority, they are hell-bent. So they will mark only one right and others wrong. Best one was that you don't have to give this option, okay? You change something like different 1 by 6 or other values. Only one is right. And if you are giving both of the option using the different formulas, then you should get marks for both of this. So I believe you got some new concept or new understanding, and this gear ratio concept is clear. Don't get confused like me, as for the first time I got confused, but after reading different books, this confusion got clear. So I believe you enjoyed this lecture. Meet you next time. Till then, have a nice day.